Okay, so now let's use the product rule in a more complicated example. And in this case, we've got the function is now the product of two much more complicated polynomials, 6x to the power of 7 minus 4x to the power of 5 in brackets. And then the second part is 1 minus x squared. So we're going to use the product rule to differentiate this. We don't want to expand this one. We're going to just use the product rule. So step one, remember, derivative of the first times the second plus the derivative of the second times the first. So if we look at this, you see the first is that. So the derivative of that, 7 times 6 is 42, x to the power of 6. The derivative of the second part, bring the 5 down, negative 20, x to the power of 4. So that's the derivative of the first times the second as is, right? Then go to the second. The derivative of the second is very easy. It's just negative 2x. The 1 disappears. So there's the derivative of the second times the first as is. And that technically is the derivative. Now, we'd like to make it a little bit nicer. So we are going to rainbow these answers. So I'm just going to rainbow the 42x to the power of 6, rainbow times 1 times negative x, and then rainbow the negative 20 times x squared. And then in the second part, rainbow the negative 2, the negative 2x. I get a negative 12x to the power of 8 and a 8x to the power of 6. Now collecting like terms, and we'll get all the x to the power of 6's together. We get x to the power of 8 first, and we get negative 54x to the power of 8. All the x to the power of 6's, and we get 70 of those, and x to the power of 4's is negative 20. And we have our derivative. Since we have our derivative, we can then go off and ask the follow-up question. So that's the function that describes all of the possible slopes. Here I want to know the actual slope at a specific x value at a negative 1. So I just need to substitute in negative 1 wherever I see an x. And of course, in this case, all the negative 1's get raised to even exponents, so they just become 1. And it's negative 54 plus 70 minus 20, which is negative 4. And so the derivative, or the slope of the tangent at x equals negative 1, is negative 4. So using the product rule, we're going to ask ourselves the exact same questions I've been asking all along. Find the derivative, find the slope of the tangent at 1. It's just we're going to use the product rule to get that derivative.